Hello, and welcome to the CIM New Brunswick branch virtual event series on an emerging gold district in southwestern New Brunswick. It's really great to see such a good turnout today. We have over 50 people. Over 50% of those people are from out of province, including 2 from overseas and 8 students, so welcome. Today we'll be talking about evaluation of gold mineralization in southwestern New Brunswick and till geochemistry database and exploration potential in southwestern New Brunswick. My name is Holly Stewart. I'm the Director of Minerals and Resource Development Branch with the Department of Natural Resources and Energy Development. I'll be your moderator today, so thank you for joining us. Some housekeeping before we get started. So if you joined with your computer audio, make sure you selected the computer audio button on your control panel. And if you dialed in with a traditional phone, ensure that the phone button is selected. The meeting duration will be approximately 1 hour and all attendees will be muted. Each speaker will present for approximately 20 minutes, followed by a 5-minute Q&A. If you have questions during the presentation, please type them into the question box in the control panel. These questions will be addressed at the end of each presentation. Follow-up contact links will be provided at the end of each speaker's presentation as well. We are pleased to inform you that the presentations will be recorded and available soon. Our first speaker today is Serge Allard. Serge graduated from the University of New Brunswick in 2000 with a Bachelor of Science degree in geology. He went on to complete an MSc in geology at UNB in 2002, specializing in superficial geology. For over 20 years, Serge has worked for the government of New Brunswick as a geologist, primarily involved with superficial mapping and till geochemical sampling programs. He's also spent time working on industrial mineral projects, various GIS and data management initiatives, and government policy. Currently, Serge is the manager of New Brunswick Geological Survey South. He's keenly interested in New Brunswick landscape and its associated to geological processes old and new. In his spare time, he enjoys trying to keep up with his boys on mountain bikes, snowboards, canoes, etc. He's also a songwriter and enjoys playing guitar and drums. So welcome, Serge. I'll stop sharing my screen and you can share yours.
That's great, Holly. Appreciate the kind introduction. Okay. Everything okay on your end?
Looks excellent, thank you.
Well, thank you everyone for taking time out of your day, especially noon hour, to tune in to talk about dirt and other things happening in southern New Brunswick. Really, I'm just the presenter of this information today. Really, who deserves credit is the superficial group here at the New Brunswick Geological Survey. That's Tone Pronk, Mike Parkhill, Will Gilmore, and I still consider myself part of that crew. And of course, people that have come before us, Al Seaman, a lot of his work here. Al is retired a number of years ago. So I think every presentation, it's kind of fun to learn some things. So I thought we'd start by talking about just what is till. I can't assume everybody knows, but it is dirt. It's a primary glaciogenic sediment. So that means that it's material that's deposited by the action of advancing or retreating glacier. It's a sediment. It's unconsolidated sediment. It's derived from the erosion and deformation of pre-existing sediments or from bedrock itself. And the English, they call it boulder clay. It's kind of a colloquial term, but it is quite informative in that it's quite a mixture of grain sizes from boulder sized all the way down to clay sized particles. A photo from a colleague and friend, Mike Parkhill here. This is just a photograph of the surface, ground surface here. But it's a pretty good example of what till is. Here you can see it's an over-consolidated, dense mixture of various grain sizes. Here we're looking at quite a variety of lithologies and some rounding. That's telling us that some of this is distally derived Contrast that with a more locally derived basal till, lodgement till again here, where you can see some of the clasts are angular, and the lithotype tends to be, it looks at least from this vantage point, that it's just one lithotype. So that would be a till that we would expect to be more locally derived. So again, a sediment born of glacial processes. Where did all this till come from? Well, during the last ice age, we were blanketed, Canada was blanketed with this continental scale ice sheet. So in New Brunswick in particular, we see sediments that, you know, this is yesterday in geological time, but we see sediments that up to about 130,000 years ago. Lots of evidence of Wisconsin glaciation. We have some interglacial Sangamonian sediments that have been dated, and a few rare instances of an older till from the Illinoisan phase of glaciation. Of course, textbooks like to show this continental scale ice sheet extending over the Maritimes, but we know that's a little more complicated. So here we talk about in Eastern Canada, Maritime Canada, we talk about the concept of an Appalachian system of glaciers here. So these are smaller domes that have interacted, coalesced in the Maritimes. And why I'm showing this, I guess, to you folks is that glaciers, they didn't always just flow north to south. There was quite a bit of interaction here in our part of the world. And it's not uncommon to find indications of glacial flow to the north, to the east, all kinds of places, as I'm sure my colleagues would attest to. So here are just a few facts about till. It's the most encountered unconsolidated sediment in our landscape. It blankets most of New Brunswick. Historically, I guess, or at least to some even today, it's viewed as a challenge in mineral exploration, and that's, I think, where the term overburden is born. But I'll make the case, and then many others would as well, that it's quite useful as an exploration medium. And what I mean there is by the concept of drift prospecting. And we believe in it so much that we've been running, and folks long before my time here have been running a till geochemical sampling program here in the Geologic Survey since the early 80s. The diagram here we're looking at on the right, a laser pointer, okay. What we're looking at here is LiDAR imagery. So this is a bird's eye view of the Earth's surface. And some processing has gone on here to strip trees off. So we're seeing the bare surface. And I thought just a neat example to show you, this is just a random example of the terrain southeast of Mount Pleasant. Notice the scale bar there, just to give you an idea of the density of our till sampling. The green sites would have been sites that were collected nearly 20 years ago, I guess over 20 years ago now, during a reconnaissance scale program. And the red sites are some more recent infilling. That's the kind of sampling that we find ourselves doing these days, just to increase density in areas that we perceive to have higher potential. So yes, you heard me say drift prospecting. Well, what is that? It's the tracing of mineral anomalies back to their outcrop source, okay? So it's very important that we understand something about the ice flow history in the region so that we find success using these approaches. So, you know, it's one thing to delineate some anomalies in till, but it's another thing to understand their provenance. So you have to employ some regional mapping to understand the distribution of glacial sediments across the landscape. And part of that, you want to look for streamlined landforms that are indicative of flow. These are things like drumlins or flutings. And at the finer scale, glacial striations and things of that nature. Now, this is just an example from the Clarence Stream trenches. And it's just to show you, this is the kind of the scratches that you see on the bedrock surface there at glacial striae. They can be indicative of ice flow direction. And so we've got two directions here. We've got the fine scratches here, and then you've got some sort of other features that are running to some angle to that. And at the other end of that spectrum, at the mega scale, Here again, we're looking at bare earth LiDAR imagery. Notice the scale bar, 4 kilometers. So what we're seeing here is, and I hope you can see it, is that the impact that the ice mass had on the landscape is profoundly shaping the landscape and causing this fabric to be developed across the landscape. So that is glacial fluting. That is also a good strong indicator of ice flow direction. The red X's here are mapped mineral occurrences, I guess just south of Fredericton Junction in that neck of the woods. Again, probably in the vicinity of Mount Pleasant in that area. And the idea here is that the glacier would have dispersed some of the indicators of that mineralization down ice. So we use that term down ice. So here I'll give you I call this my 1-minute drift prospecting course. This is just a road cut photograph I took near St. Stephen, but it shows that line delineates the contact between the overlying lodgement till. Again, think about that term boulder clay, these large clasts that are tied into this finer matrix. Very nice basal till here. And then this is bedrock beneath. So let's imagine that you've got some mineralized vein or something like that. Ice flow direction this way. So the premise is that some of the indicators of that mineralization would be transported down ice. There'd be a plume that would develop in the till. And hopefully one of our guys comes along and collects a regional till sample that gives us some indication that there's something interesting in the area. I just scabbed this off the internet. Same sort of thing, except this time ice coming from the right side of your screen towards the left. But it gives you a look at it, plan view, cross section, and the longitudinal section. Again, to show you the migration of that mineralized plume in the till. So that's what the whole premise here is, that you're creating targets that are much larger than just trying to find that small indication in mineralized bedrock. So what are some of the advantages of drift prospecting? Well, it's a proven method. It's cost effective. It helps the chances of finding exploration targets. And of course, we've got a global network of analytical services labs that can be relied on for analyses. Disadvantages? Well, of course, it's only applicable in glaciated terrain. So in that way, it is contingent on the presence of till. The people conducting the survey have to have some competency in identifying and distinguishing superficial units. You got to be able to identify the stuff. And of course, things can become a little bit complicated with complex glacial history, but for the most part in New Brunswick, it's fairly straightforward. And of course, back to the analytical methods, they all have their pluses and minuses, depending what system you're chasing and what elements you're considered to be pathfinders. Well, there are some methods that are better than others. And I don't know if Rod's going to talk to us about that, but certainly there would be folks on the line who would know all about that. Okay, so this is us. We move into, I'll show you a little bit of our data. This is the crew. These guys in the upper left corner here, Al Seaman, Tone Pronk, Mike Parkhill. They've dug a lot of holes, a lot of dirt. We call ourselves dirt baggers. Folks like Will Gilmore and myself came along a little time after. Numerous summer students have come through this program here at GSB. We've been employing summer students. In fact, I was a summer student. Mike Parkhill was a summer student. Many of us got our start digging till pits. And at times we've involved, GSC folks and other universities and such that have helped with this as well. Yeah, it's just a superficial map here to show you that we don't just dig holes. We do produce superficial maps as well, and they're handy tools. Do that in our spare time, I guess. So yeah, there we go. The cartoon you see on the right is the density of stations across the province. So we're quite proud of this. It took a long time. It had its origins back in the early 80s. Scandinavian countries were finding some success with till geochemistry, and we weren't far behind here in Canada. So by 1986, We had embarked on a full-scale regional campaign to systematically sample till across the province. So to date, I think it says over 15,000, but I think it's closer to 20,000 individual stations. That's the result of over 50 individual field projects. Lots of work done here. Areas of high potential have more density of samples than areas of that we perceive to be of lower potential. But that gives you a good idea of what the distribution across the province looks like. It's an in-demand data set for sure. And we've published this for those of interest that want to get their hands on this important data. There are a series of open file reports here that compile the data per region of the province. Here we are. So those are the open file numbers. And I think there's been some updates recently for the southern reports, but you should be able to find those. And we're not just talking the chemistry here as well, although that's the most important bit perhaps, but all of the field observations. There's grain size analysis run on a lot of these samples, and also an evaluation of the lithology of the pebbles within the till. So that tells us something about their provenance or how far things have transported relative to underlying bedrock. So all of this is free from our website. And future plans, well, we're hoping to develop some sort of ArcGIS online or a web map service of where people can interact with this data via some sort of digital atlas. So that's something that we're currently putting some effort to. That's what the till pits look like. So material just dug below the zone of weathering, and one bag of dirt and the other bag of pebbles for identification. Some of the guys in action here. Recently, we moved to collecting all of our data digitally with these field tablets. Yeah, so this is the kind of thing we're talking about with this digital atlas. We'd like to produce value-added products for our clients. So here we're looking at southern New Brunswick. We're looking at the arsenic concentration in till, and right away some trends show up here. Be mindful of the legend down here in the left corner. The gray dots indicate the 95th percentile, or what we would consider threshold anomalous. 98th percentile, the black dots, we would consider those anomalies or anomalous. And of course, I'm showing just where the real highs are. That's material that's above the 99th percentile as red dots. So we add a few place names there, and some trends start to show up. Of course, the Burnt Hill area, Sisson, where we know there's quite a bit going on. So arsenic is a good indicator of what's happening at Sisson. The Poplar Mountain gold deposit shows up. That's Lake George antimony mine, or past producing antimony mine. And of course, a pretty good indicator that there's something special happening down here in the southwest. And this is what we're starting to be referred to, I guess, as an emerging gold district. Antimony, again, this time the Annidale belt is really popping. We know there's very prospective areas for antimony in that area. Lake George is sticking out. We've got Clarence Stream. Whole heck of a lot going on up here. I'm not sure all of this has been fully evaluated or characterized, but of course Sisson is sticking out, Poplar Mountain again. Tungsten is an interesting one. A lot of tungsten around Burnt Hill, and of course that's well understood. We've got this nice feature emanating from the Sisson area here. Place names on. Mount Pleasant, although Mount Pleasant's funny. We didn't get a great signature at Mount Pleasant. We do get some material down ice. It's oftentimes hard to distinguish if it's dispersal or just indicating other point sources down here, which I think is the case, but Mount Pleasant is somewhat masked. It's not a great expression of tungsten there. Tungsten not being a great element anyway, but let me zoom you in. I thought it'd be interesting to just have a peek at this area, Sisson, just as an example. So here we're looking at quite a well-defined dispersal train. This would be the Sisson proper occurrences here. And you see this is a nice dispersal train, but not the orientation of that dispersal train doesn't line up with expected trends in the LiDAR or on the ground. But I've just plotted here roughly the two main directions of transport. So this is what we call a palimpsest dispersal train. It's taking on the qualities of two phases of glacial dispersal. And it kind of approximates these two directions. Combine them, kind of interesting. Al Seaman has a detailed paper about the till in this area and dispersal patterns. So if anybody's interested in that, I'm sure you could find more about it. But let's focus a little bit down in the southwest, because that I know that's of interest to what's happening here today. So arsenic by INA going on there. Good indicator. And just to show you that that's just an example to zoom in an area, just to show you that when you start, it really gets meaningful when you start to overlay the some of the road infrastructure and the red X's indicating mineral. And this is the kind of product we hope to at some point be able to deliver online sometime. Gold, well, why didn't you show gold first, Serge? Someone could say, but gold is not, you know, we always try to steer people to the pathfinders. Gold is subject to the nugget effect. It's not often reproducible, but still here, ignore that density. We took a lot of samples of ICP gold at Clarence Stream, but that sort of skews things here. But I'll just show you gold by INA. So gold by INA, these are the same samples analyzed, just using a different method. And see if I toggle back and forth, it paints somewhat a different picture. Now, that's not to say that gold is not meaningful. I think any highs in gold warrant some follow-up, especially if there's a clustering of samples. But and just a few more here, Holly, and we'll be able to move on to the next speaker. Bismuth, I think, is one that folks should consider as a good pathfinder for this emerging gold district. I think it's a good indicator. Molybdenum as well. It's proven to be a good indicator of what's happening in this region. Tungsten, yeah. But of course, tungsten is skewed so much by what's happening in the Burnt Hill area, where we have such highs that they sort of mute things down here. So I think if one really wanted to dig into what's happening here in the Southwest, you may want to trim your data set to eliminate some of that. And look, I could go on and on about this, but I think I've just about run out of time. So I'll say thank you and show this picture of my friend and colleague, Tone Pronk, who, not to say too much, but I think Tone is retiring at some point in the future, and we wish him the best in his endeavors wherever he finds himself. Thank you.
Thank you, Serge. Excellent presentation. So now we're ready for a Q&A. We have a few minutes, and if you have questions, please put them in the chat box. And perhaps, Serge, you could also share your email address in the chat box in case anybody would like to follow up with you.
Yes, yeah, you did tell me to do that. Not a good listener.
Thank you.
Where would I find the chat box?
So down along the bottom, maybe after you stop sharing your screen,
Okay.
you'll see it better.
Sure. Oh, here we go.
Okay, there's no questions for Serge right now. We'll move on. Okay, our next speaker is Rob Burchard. And Rob obtained his BSc in geology from the University of New Brunswick. He has over 20 years experience in mineral exploration and prospecting. And early in Rob's career, he spent time working on diamond projects in northern Saskatchewan, gold and base metal deposits in Ontario, uranium deposits in Nunavut, and IOCG deposits in Nova Scotia. The majority of his career has been prospecting and managing exploration projects in New Brunswick, including Nash Creek and Nipissing base metal deposits in the Bathurst mining camp, Sisson tungsten moly deposit, Battery Hill manganese project, Bald Hill antimony, and numerous gold deposits, including Cape Spencer, Devil's Pike, Golden Ridge, and Clarence Stream. Currently, Rob is a bedrock mapper for the province of New Brunswick's Geological Surveys branch. Welcome, Rob.
All right, thank you, Holly. All right, good afternoon, everybody, and thank you for taking the time to come out to our New Brunswick CMN talks today. Today, I'll be giving a brief evaluation of the gold deposits in southwestern New Brunswick. I'll just give a quick summary of the mineral occurrences found in southwestern New Brunswick and where they're located. Then we'll focus on some of the current gold projects that are being explored in southwestern New Brunswick and what kind of deposit types that can be found. The current projects that we'll review are the Devil's Pike and Bald Hill deposits held by Globex Mining Enterprises, the Cape Spencer and Hawkins Love projects held by Magneterra Minerals, the Fundy Gold project that's being explored by Brunswick Exploration, and finally the Clarence Stream project Galway Metals has been exploring for the past few years. Here's a map of the lithotectonic subdivisions of New Brunswick, where the main gold projects are located. So you can see the Devil's Pike deposit is located up here in the Annidale belt. These are some late Cambrian to Ordovician rocks, and as well as a similar environment, Clarence Stream in the St. Croix terrain, which is also being intruded by the St. George batholith. Some of the older rocks in New Brunswick along the Caledonia terrain, we have the Cape Spencer project, and over towards Fundy Gold within the Brookville and New River belts that are also associated with the Kingston and Mascarene Silurian copper rocks. Up here, the big part of New Brunswick, that would be the Lower Devonian, Permian Maritimes Basin. And down here, we got a little bit of the Mesozoic Fundy Basin, where everyone's favorite place to go hunt dinosaurs. So this map shows the mineral occurrences and claim holdings in southern New Brunswick. There are 392 mineral occurrences. 98 of them are gold occurrences. We have 153 copper, lead, zinc, and nickel occurrences, 44 tin, tungsten, moly occurrences, and 7 antimony occurrences, as well as 90 other occurrences with different commodities, including iron, manganese, as well as many others. Some of the larger claim holders in the region include Brunswick Exploration, which is right down here. That's their Fundy Gold project. We have Galway Metals up by the Clarence Stream deposit right here. Globex Mining here in the Annidale belt with the Devil's Pike and Bald Hill deposits. We also have Gold Star Metals, who have some claims up around the Lake Pass producing Lake George mine, as well as in around the Mount Pleasant area. Some of the other major players in the region, Great Atlantic, they're currently exploring down in the Mascarene belt. We have Magneterra Metals with Cape Spencer and their Hawkins Love project. These claims here are held by an individual called Ryan Kalt, who staked quite a few claims in the past year. And Slam Exploration also has quite a few different projects in the area. So this map shows the mineral occurrences with the geology and some of the major fault structures. Notice the majority of base metal deposits and gold deposits are located near these major structures that cut across southwestern New Brunswick. You also have some gold occurrences located around the felsic intrusions, as well as a lot of the tin, tungsten, and moly occurrences are also around these felsic intrusions. Over here in the southwest, that cluster of nickel copper deposits related to some mafic intrusions around the St. Stephen area. Because of the diverse geological environments found in the southwest part of the province, there are several different gold deposit types that are presented. Ones highlighted in this presentation are the orogenic gold deposits that are mainly focused around the structural corridors, and the intrusion-related deposits that are related to the felsic intrusions. There's also some potential for IOGC and porphyry copper gold. So here's just a little schematic showing the key geological environments. Note the depth chart here over on the left-hand side. This is modified from Polson, Annidale, and Robert. We have the Annidale, Cape Spencer, and Fundy gold projects. They're all orogenic mesothermo deposits that are generally hosted in brittle ductile shear zones hosted by quartz carbonate veins. And then we have our Clarence Stream deposit here, which is a reduced intrusion related system, which is mainly hosted in sediments. And over here would be an example of the Annidale copper porphyry system. So starting out in the northeast of our area of interest is the Annidale Gold Belt, which hosts several occurrences that exhibit typical mesothermal orogenic deposits. The Annidale Belt consists of late Cambrian to Ordovician, mafic, and felsic volcanic rocks and sediments. And they're overlain to the north by the Carboniferous cover, and they are fault bounded to the south by the Taylor Brook fault, which separates them from the Silurian Mascarene Brook, or Silurian Mascarene group, sorry. To the southwest of the map area, the Annidale group rocks are separated from the Fredericton cover sequence to the north by the Pender Brook fault, and are also intruded by felsic intrusions of the late Silurian to early Devonian St. George batholith. There's also a number of major northeast trending faults here shown in the black dashed lines, as well as a few northwest faults that are internal to the belt. They consist of mainly steeply dipping normal faults, as well as some thrust faults, such as the Albright Brook fault to the north, right there. So there's 27 known gold occurrences in the Annidale belt. These occurrences occur over a 50-kilometer strike length and include the Harry Brook occurrence, where Sue Johnson found a boulder grading 1,320 grams per ton gold. Then we have the Sheba occurrence, where a grab sample of 22.5 grams per ton was found by a prospector. The north and south Fuchsite zones, they have some drill intercepts on them. One of the better ones being 3.12 grams per ton gold over 1.52 meters. And then we have East Scotch Settlement, where we've had a chip sample from a shear zone in a trench that returned up to 39 grams per ton gold. Down in the far southwest of this map, we see the Annidale gold occurrence, and that's one of our examples of kind of a gold copper porphyry system. And that's hosted by the late Devonian Annidale granite. The majority of the mineralization in that deposit occurs along northwest trending fractures. And consistently, the fractures have some chalcopyrite and minor molybdenite associated with some narrow quartz veins. There was some drilling done by Dome in 1980 where they intersected a high-grade interval that yielded 16 grams per ton over 20 centimeters with some decent silver, copper, lead, and zinc. Now moving on to the Bald Hill and Devil's Pike deposit, which are two of the more explored deposits in the Annidale belt. The Devil's Pike Brook deposit contains some of the highest gold grades in the Annidale belt, and they're set in a northerly trending on echelon quartz veins hosted by mafic volcanic rocks. The gold at this deposit is associated with chalcopyrite and quartz, which exhibits a brecciated texture. There is a 43101 resource estimate done on the main and parallel veins here at the Devil's Pike, and they contain a total of 66,300 ounces inferred cut, and when it's on cut, it was greater than 90,000 ounces of gold. 4 kilometers to the northwest, we get the Albright Brook showing up here, in which Rockport Mining drilled hole DP36. That intersected 0.56 grams per ton over 21.52 meters. And this was hosted in a really highly altered, highly deformed section of the Cameron Road granite. Follow-up drilling a couple years ago also intersected some small, massive stibnite veins in that area. A lot more work needs to be done to fully define that deposit. And then now we go to the west, to the Bald Hill area. It's important to note that there's not a gold resource or antimony resource for that matter defined. The deposit was covered in the 2000s by the late Bill Carter, and then was followed up by drilling by Rockport Mining. Roscoe, Posco and Associates did a scope on it, and they estimated that the deposit could contain up to 1 million tons of antimony. And there is gold associated with this deposit. It's kind of in with a arsenic, in with a lot of disseminated arsenic that kind of forms a shell around the massive stibnite and quartz vein. So down along to the Cape Spencer project along the Bay of Fundy, this is another example of another orogenic gold deposit. And it's hosted along shallow thrust faults within deformed Neoproterozoic granitoids of the Caledonia terrain, as well as some also some quartz veins with some gold that intrude the carboniferous sedimentary rocks that cover. The gold in the Cape Spencer deposit is mainly associated with disseminated pyrite within oolitic altered host rocks, and there's variable amounts of specularite, chalcopyrite, and iron carbonate, as well as there are some locally high-grade gold veins that cross-cut these host rocks. And there's approximately 5,000 ounces of gold that was extracted by heap leach operation during the 1980s. And then most recently, Magneterra Minerals completed a 43101 resource estimate on the pit and northeast zones, where we have a resource estimate of 1.72 million tons at an average grade of 2.72 grams per ton gold, for a total of 151,000 ounces of gold for the pit and northeast zones. Other gold occurrences in the Cape Spencer include the Birches zone, where there's been drill intercepts of 5.43 grams per ton over 4 meters. The Emilio zone, which has 7.86 grams per ton over 4 meters. Right now, Magneterra currently has a drill program in that area, and I'm pretty excited to see what they get in this newest program. Further along to the northeast, there's the West Beach A and B zones, where there's been up to 53 grams per ton in grab samples. Gold Brook had a channel sample of 7.75 grams over 3 meters. And then up to the far northeast is the Marigold project, which had some drilling that returned 8.71 grams over 2 meters. And this is their Hawkins Love project, which is located a little bit to the west of Cape Spencer. It's along a 10-kilometer section of the Back Bay Fault and underlain by Silurian, Devonian, St. George Plutonic Suite, the Jake Lee Mountain Granite, and then there's the Silurian Mascarene group volcanics and sedimentary rocks, and some fault-bound slices of the Proterozoic New River Granite Suite and volcanics. Only a bit of historic exploration has been on this property from 1969 to 2013. It's been mainly focused on base metal sulfides and rare earth elements. And but there was a nice B horizon soil samples collected in that area, and showing a nice northeast trend soil anomaly. There's also been a little bit of ground magnetics and electromagnetics flown in the area, but minimal diamond drilling has been occurred in this area. A lot more work needs to be done on this deposit as well. The anomalous gold you see here, that's about an 8-kilometer strike length of gold anomalies along these structures, with 44 samples being greater than 10 ppb gold and 11 samples greater than 50 ppb gold. The Fundy Gold project is currently being explored by Brunswick Exploration. This area here has seen very little exploration. Most of it was done in the 1980s after the Cape Spencer deposit was found, but very little work has been done since. It does host 21 historical mineral occurrences, some of which include the Shadow Lake and Little LaPro over here, that's along the Spruce Lake shear zone. At Shadow Lake, prospecting samples have returned up to 2 grams per ton gold and 939 grams per ton silver, over 3% copper, almost 2% antimony, and over 24% lead. At Little LaPro, some prospecting samples have returned up to 67 grams per ton gold, 17 grams per ton silver, and over 0.5% copper. And that was in some angular, and near that one recently, there's been some angular float that graded 0.35 grams per ton gold, 1,500 grams per ton silver, over 7% copper, and 5% antimony, and a little over 1% zinc. So they're getting some pretty significant grades in their prospecting samples on this project. And they recently, Brunswick Exploration completed a B horizon soil survey near the Rogers Lake occurrence. And they've gotten a 5-kilometer golden soil anomaly identified there. And they even had one spectacular sample that returned 16.2 grams per ton in soil. And I expect Brunswick Exploration is going to have a lot of fun following up these soil anomalies in this area here. It's important to note the old LaPro iron mine has been recognized as a possible IOGC deposit. There's not a whole lot of references around southern New Brunswick for IOGC deposits, but right across the Bay of Fundy in Nova Scotia, they've been exploring for these IOGC deposits, and I expect we'll, find some indications of these hopefully in the near future. Down by the coast, this is where the majority of the gold occurrences have been found. They've gotten 39 grams per ton at the Gooseberry Village, Little Dipper Harbor, they got 26 grams per ton gold, 200 grams of silver. And then at Musquash Harbor, we got up to 8 grams per ton gold with some other silver and copper numbers and lead. This is from Brunswick Exploration's recently soil grid that they've done across the 7-mile Lake Metamorphic Suite. Great looking anomaly that they've identified here. This just came out this year. And 25 of these samples came back greater than 50 ppb gold. Like I said, I think they're going to have a lot of fun following up these soil anomalies along this 7-mile Lake Metamorphic Suite. It looks like they're off to a great start with their exploration program this year. Now we're going to move on to Clarence Stream. This shows the extent of Galway Metals claims. To the east of the Mount Pleasant mine here, we have some chip samples that graded 17.9 grams per ton gold. It's these here around the Jimmy Hill and the John Lee Brook granites that intrude sediments of the Flume Ridge and Sandbrook formations, as well as the Kendall Mountain Formation sediments in the St. Croix Belt. But today we're going to focus more on these deposits to the southwest of Mount Pleasant, where they've drilled off 8 known gold zones to date. The first one being the south zone here that was discovered in, let's go to the next slide here, in 1998. This slide here shows the background is the regional teal geochemistry that Serge was shown in those bubble plots, laid on top of some B horizon soil samples that Free US, Galway, and others have completed. You can see that the gold lights up quite a bit in these areas, and they've had a lot of success following up these golden soil anomalies. We have the first zone discovered by Reg Cox is the south zone over here in 1998. Free West then did this large soil grid here, and they did some prospecting up around, did some drill holes in 2001, discovered the north zone. Union Gold were also working around that same time in 2001, and they discovered the Jubilee zone just to the southwest of there. And most recently, the George Murphy zone right here was discovered in 2017, where Galway Metals was drilling for almost about a year and a half when they moved their rig over to the Richard zone, which was in a 3-kilometer gap between Jubilee and the George Murphy zones. Their first drill hole was on a little soil anomaly. They set the collar up just to the north, and they hit another zone with their very first hole there. Since then, I'd say they've probably drilled over 100 holes on the GMZ, Jubilee, and Richard zones, and as well did some more exploration drilling, which discovered a new zone north of the George Murphy zone, now called the Adrian zone. And even another 600 meters to the northwest of that, they discovered another unnamed new zone. And then another discovery to the 900 meters west of Jubilee, where they've got 186 grams over 0.6 meters in a drill hole. All these, right now, Galway, I believe, has up to 6 diamond drill rigs drilling. They're really want to get a new resource on the Richard zone, George Murphy zone, and Jubilee. There's about a 2.8 kilometer strike length there. Right now, the only resources at Clarence Stream are the south zone, where there's over 400,000 ounces. Defined, measured, inferred, and indicated and inferred resource total, plus the north zone with 103 ounces of gold at 1.98 grams and an inferred resource of 123. So a little over 600,000 ounces defined to date, but many new discoveries and hundreds of drill holes will be put into their next resource estimate. So a little closer look at the south zone. This one here, we know it has a direct genetic relationship between the gold and the early Devonian macadamic granite shown down to the south here. It's associated with abundant arsenic and antimony, and occurs within quartz veins and as disseminations. Within the Silurian metasedimentary rocks and Metagabaroa coast rocks, and also some apelite pegmatite dikes that grade laterally into gold-rich quartz veins. This deposit does remain open along strike and at depth, and more drilling needs to be done here to upgrade this resource. Right now, it's defined over 2.4 kilometer strike length. Within the gold-bearing veins, we do see lots of good, coarse, visible gold. Arsenopyrite's very common, as well as stibnite and native antimony, and also sphalerite. I think there's greater than 261 drill holes right now that define the 441,000 ounce gold resource. Up to the north zone, we have the Clarence Stream, what we see in the background is our B Horizon soil sample grid, showing all the anomalies and all where all the drill hole locations are located. The North Zone is hosted entirely in the Kendall Mountain Formation sediments. It's quite a bit different host than the South Zone. Consists mainly of just thick beds of medium grain quartzites and gray wackies, and these are interbedded with some thin shale and siltstone beds. The mineralization here is also more shallowly dipping folded quartz veins with strong sericite alteration and disseminated arsenopyrite and stibnite. There's not as much visible gold in this deposit, but we do see it in some drill holes. The South Zone for certain has some really beautiful visible gold. And then here are the newest discoveries that Galway's found over the past 4 years. It shows the GMZ up to the northeast here. Along strike, we go down to the Richard Zone, and then followed up by Jubilee. And then there's a new discovery down to the southwest corner here, the Adrian Zone, which was most recently discovered north of the George Murphy. And another one kind of all by itself that needs some follow-up drilling here is another new discovery they have found within the past year. At the George Murphy Zone, mineralization is hosted in subvertical quartz veins that appear to follow the axial planar cleavage of an antiformal folded sediment package. And there's also a few mafic dikes that cut across these sediments. The mineralized veins generally contain quartz visible gold with pyrite, pyrrhotite, arsenopyrite, and minor stibnite. The Richard Zone is hosted by medium to fine grain Horsfeld sediments that are intruded by fine grain mafic dikes, and they're in close contact to this granite to the north. Same with the Jubilee. It's a very similar host rocks in these deposits. To sum it all up, much of southern New Brunswick is underexplored for gold, and the geologic setting comprises of several geological environments, many of which provide favorable conditions for the formation of several different types of gold deposits of variable ages, from the Neoproterozoic to the Permian. Intrusion-related gold and orogenic types are the most common deposits found in southwestern New Brunswick. And the main exploration targets include all the major structures and felsic intrusions. And there's other potential deposit types that may be found in southern New Brunswick, include the IOGC deposits, as well as copper, gold, porphyry. To explore for these, soil geochemistry works great in New Brunswick. It's been proven successful many times over by prospectors and exploration companies, as well as using some geophysical techniques like magnetics and resistivity, which are good for locating major structures, intrusions, and formational contacts. And the new advent of the LiDAR imagery, which we have available in New Brunswick, these also really help in identifying faults, glaciated features, and areas of outcrop. I'd like to thank the CIM team, Tom Healy for organizing everybody, Adrian Park for getting this set of talks together, Elaine Kinsella for doing all her hard work with her advertising and getting all these people out today, and Holly Stewart for hosting this session. And I'd also like to thank Brunswick Exploration, Magnetare Minerals, and Galway Metals for providing some of their information from their website, as well as Sue Johnson, who helps me every day here in the office. If you want to find out more information on these projects, you can go on to their websites. They have a lot of information there. And if you want to look up more on our mineral current database, just go to our website, and there's a link. You can sort all different ways to look up all the information on these mineral occurrences. Any questions?
Thank you, Rob. Great presentation. So now we're ready for questions. So to get started, we have a question from Tom Healy. Are the fault systems shown identified by geophysics or mapping or both?
That would be both. There's been numerous airborne mag studies that been flown across southern New Brunswick at different times. I think in the St. George region, St. Stephen, St. George, it was a 2002 study. These here are all available on the GSC website. And then also, some of these have been mapped out in the field, but since we do have quite a bit of cover in New Brunswick, a lot of these faults are hidden. But if you actually look at our LiDAR data, they really do pop up and, complement those aeromag surveys.
Thank you. We have time for one more question from Paul Robinson. What is or are the mechanisms for the preservation of epithermals in New Brunswick?
Ooh, epithermals, the one I didn't cover. There is an epithermal deposit classified in the southeastern part of New Brunswick, but not a whole lot of work's been done on it. That one there would be the chamber settlement deposit, but yeah, I don't know a whole lot on that one.
Okay, thank you for the questions. Thank you to Serge and Rob for presenting. And thank you to everybody for attending today. Our next session will be on Thursday, April 29th from 12 until 1. The speakers will be Nicholas Piet-Lazier, who will be speaking about deformation, alteration, and mineralization in the Pokalogan myelinite zone, Southwest New Brunswick, as well as Adrian Park, who will be speaking about carboniferous structure and IOCG mineralization in Southwestern New Brunswick. We look forward to you attending. In addition, please take note that the CIM 2021 virtual convention will be held between May 3rd and 6th. Registration can be found at registration.cim.org. I'll pause for a minute in case you want to jot that down. Thanks again to the speakers, Serge and Rob, and thank you for attending. We look forward to you joining us on April 29th for part 2 of the CIM New Brunswick branch virtual event series on an emerging gold district in southwestern New Brunswick. Have a great day.